Okay, good day. So this is the second video about applications of indefinite integration. And the second application is about rectilinear motion. And when we say rectilinear motion, ang motion ng ating particle or moving objects is along the straight line. And you already have a background about rectilinear motion nung junior high school kayo sa topic na physics. Okay? And from the previous lessons natin, sa third quarter, dinefine ko yung velocity v of a moving particle or object as the time rate of change of the distance s. Okay, in symbol we write v equals ds over dt. So if we have a distance function, if we get the derivative or the first derivative of distance function s of t, the resulting value is actually the velocity function. At kung natatandaan nyo sa topic na nating higher order derivatives, na-discuss ko to sa inyo. Okay? When junior high school kayo, dinefine yung velocity as distance over time only. But this time, velocity is time rate of change of the distance s. And also, dinefine ko rin sa inyo, sa topic na higher order derivatives, that acceleration is the time rate of change of the velocity v. In symbol, we write dv over dt. So, ibig sabihin, yung first derivative of the velocity function is equal to acceleration function. Okay? So, sa mga tuwid, if we get the second derivative of the distance function. So, ang derivative niyan ay d squared s over dt squared. Yan yung second derivative, okay, ng ating distance function. Equal din yan sa acceleration. Okay? Ibig sabihin, first derivative ni velocity function equal to acceleration, and second derivative of the distance function is also equal to acceleration. And we have solved problems dealing with these quantities from dun sa ating previous lesson natin sa higher order derivatives gamit yung process of differentiation. This time, in this topic, we're going to solve problems by the use of integration naman. Okay? So this is the second example on the applications of indefinite integration. And it says, a body is thrown vertically upward from the ground with an initial velocity of 96 feet per second. Find the maximum height attained by the body. So ito talagang topic na to is freely falling body. Okay? Kung natatandaan yung junior high school kayo, this is freely falling body. Now, to solve this problem, define muna natin yung mga variables natin. Okay? Start tayo kay S. Sabihin natin si S is the distance. Okay? Pagkatapos T, time. And then A, acceleration. Okay, yun yung ating mga variable. Now, ano bang given natin doon sa ating problem? So, meron daw tayong object of body initya pataas. Simula sa ground. Ang initial velocity niya, 96 feet per second. So, ang given natin, initial velocity. So, initial velocity. And that is equal to 96 feet per second. Okay. And then, mamaya ko na ilalagay pa ibang given natin. Ang tinatanong sa atin ay maximum height. Okay? Required is maximum height. Yan. Okay? So, para maintindihan pa natin yung ating problem kung paano natin solve, gawa tayo ng illustration. So, meron tayong object. Okay? Sabihin natin yan yung body natin. Ito yung ating ground. Okay? Init siya pataas. Okay? Init siya pataas. Okay? Sabihin natin na andito na siya. Siyempre, babagsak. Okay. Now, sabihin natin, ito yung ating max height. Okay? maximum height. Okay. Now, ito yung ating reference line natin, yung ground. Okay. So, dito, alamin natin muna yung mga values of velocity and acceleration. Kapag pataas yung ating object, ang ating velocity, our velocity here is greater than 0 or positive. Okay? And our acceleration is less than 0. Bakit? Kasi ang gravity natin nag-i-imparts ng acceleration kapag pababa. Okay? Kapag pataas, pa-decrease ang ating velocity. Therefore, nagdi-decelerate yung object. At kapag pababa naman, nag-i-increase yung kanyang velocity. Therefore, nag-accelerate yung object kapag pababa yung direction niya. Okay? Now, so dito, ang initial velocity niya ay 96 feet per seconds. So, alamin natin yung mga katotohanan tungkol do sa values of velocity, acceleration, and distance at t equals 0. Okay? Kasama na rin ito sa given. At t equals 0, so nandito yung object. Okay? At t equals 0, ang kanyang velocity is 96 feet per seconds. Okay? What else? At t equals 0, ang distance niya from the ground is also equal to 0. So, s equal to 0. Kasi ito yung ating reference line. So, pag tumaas siya, nagkakamera siyang distance from the ground. Pero at t equals 0, ang velocity niya 96 at ang distance of the object from the ground is also equal to 0. Okay? Ano pa? At the maximum height, ang ating velocity is equal to 0. Okay? Ano pa ba? Bakit v equals 0? Kasi titigil siya dun sa taas. Okay? Bakit siya titigil doon? Kapag hindi siya tumigil, hindi siya bababa. Okay? So therefore, kapag natin niya yung pinakamataas yung marating, titigil yung object and then bababa na siya. Okay? So therefore, at the maximum height, velocity equal to 0. Okay? At the ground naman, s equal to 0. Okay? So dito sa ground, s equal to 0 kasi naroon yung ating reference line. Okay? Paano natin masosolve yung maximum height na na-attained ng ating object na hindi siya pataas? Sisimulan natin to dun sa ating first definition ng ating acceleration, which is the time rate of change of the velocity v. So, ito yon. So, our solution, we have acceleration is equal to dv over dt. Okay. Ano bang ang value ng ating acceleration o gravitational acceleration natin? Since this is freely falling body, we're going to use the value of g for our acceleration. Dalawa yon, we have mataas siya, no? So, negative siya. So, we have negative 9.81 meter per second squared and the other one is negative 32 feet per second squared. Okay? Since ang unit ng ating velocity ay feet per seconds, we're going to use negative 32 feet per second squared as the value of our gravitational acceleration. So, therefore, dv over dt is equal to negative 32 feet per second squared. So, i-remove na muna natin yung unit ng ating acceleration. And then, gamit yung concept ng differential equation sa separation of variables, separate natin yung dv dun sa dt. So, we separate natin sa dt. So, we cross-multiply dt to the other side. So, we have dv equal to negative 32 dt. And then, integrate natin both sides. So, integral of dv is v. We have negative 32t, okay, plus a constant c. Sabihin natin this is constant c1. If t equals 0, v is 96, okay? So, we can solve the value of C1. Okay, so solving C1 to determine the velocity function. Solving C1, that is if t equal to 0, velocity equal to 96. Okay, so we have 96 equal to negative 32 times 0 plus C1. Okay, lipat. So therefore, C1 equal to 96. So therefore, our velocity function is equal to V negative 32t plus 96. Okay, so meron na tayong velocity function. Okay, solve na natin yung time na kung saan yung ating object or body ay nasa maximum height. Okay, paano yon? Simple lang, yung object ay nasa maximum height kapag ang kanyang velocity ay 0 kasi titigil siya doon. Okay? So, ang kailangan kasunod natin gagawin, solving t at the maximum height. Ano yun? That is v equals 0 at the maximum height. Okay? So, we have, from here, we have v equal to negative 32t plus 96. So, v is equal to 0 at the maximum height. Negative 32t plus 96. Lipat si negative 32t. 32t equal to 96. Divide both sides by 32. Therefore, we have 3. Okay? 3 seconds. So, ibig sabihin, yung ating object ay nasa maximum height after 3 seconds na na-reach yung ating object pataas. Okay? So, ito yan. Hindi pa nasagot natin. Ang kailangan natin ay maximum height. Okay? Pero alam na natin, at 3 seconds, naroon na siya sa maximum height. Anong kasunod natin gagawin? Kailangan natin ng distance function. Solving S of t. Okay? S of t, ito yung distance function natin. Paano natin makukuha yung distance function natin? Sa aking definition sa previous video ko about rectilinear motion, ang ating distance function can be determined from the formula of the time rate of change of the distance natin, s. So that is velocity is equal to ds over dt. Okay. So makukuha natin si distance function. Paano? Isa-substitute lang natin yung value of velocity from this differential equation. Okay? So therefore we have ds over dt equal to negative 32t plus 96. Okay? Cross multiply si dt by separation of variables. We have quantity, hatiin ko na, negative 32 integral of t dt plus 96 integral of dt. Okay, diniretso ko na. And then, integral of ds is s. So, we have negative 32 t squared over 2 plus 96t plus a constant c2. Gamitin ko na yung c2 kasi may c1 ako doon. So, we have now the distance function of s equal to negative 16t squared plus 96t plus c sub 2. Actually, kulang pa yan. Di pa yung distance function kasi meron pa tayo sa constant na c sub 2. So, kailangan ma-solve natin c sub 2. Okay, haba ng solution. Solving c sub 2. Paano yun? Alam natin kapag si t ay equal to 0, si s is also equal to 0. Okay? Kasi ibig sabihin nun, yung ating object ay nasa ground pa. Okay? Next, substitute. So, 0 here, negative 16, 0 squared, plus 96 times 0 plus c sub 2. Therefore, c sub 2 equal to 0. Okay? Kasi 0 to, 0 to. Teka, magdidikit. C sub 2 natin ay equal to 0. Okay? So, ang ating equation now will be s equal to negative 16t squared plus 96t. So, c sub 2 is 0. So, hindi na natin kailangan ilagay yung 0. So, ito na yung ating velocity distance function. And the last step is determine the maximum height reach of the body. Kailan yung ma-attain yun? Kapag makalipas ang 3 segundo. So, therefore, we have s equal to negative 16t squared plus 96t. So, maximum height s is negative 16 times 3 squared plus 96 times 3. Okay? Therefore, s equal to, so gamit yung ating scientific calculator, we have negative 16 times 3 squared plus 96 times 3 is equal to 144. So our answer is 144 feet. Okay? Ito yung maximum height na pwedeng maabot ng ating object kapag initya siya pataas with an initial velocity of 96 feet per second from the ground. Okay? So, initya siya from the ground, 96 feet per second ng kanyang initial velocity. At mararating niya ang 144 feet at 3 seconds. So, that is example number 2 on the applications of indefinite integration. Thank you.